Hello. Good morning, Elaine. Good morning, Alexis. Emmett's still asleep. Hopefully. Alright, I'm gonna get started here. Today's lesson is about factoring four-term polynomials. So these are going to another degree here. Note how we have a y cubed here for our first example. So they do take it to the next degree of polynomial with this, and you'll note that we do have four terms. 1, 2, 3, 4. These can be factored as well. It just takes a little different work to do it. But it's all about what can you divide out of these things. So the first thing you're going to do in step one is you're going to group them. So I'm going to come over here, I'm going to write, if it's going to work, step one, I want to group them. And I'm going to group them just by underlining them here. I'm going to underline this together, and I'm going to underline this together, keeping in mind this plus sign goes with this term here. So they are now grouped. Good job. Step two is to factor each group. And this is going to be the kind of factoring where you look at it, okay, what can I divide out of both of these terms? This is y cubed and this is 3y squared. What common factors do they share? Well, this one doesn't have any number except for 1, so there's not going to share any numbers, because if I divide by 1 it doesn't change anything, so I do it. But they both share a y squared, so I'm going to divide each of these by y squared. And when I factor out the y squared, it's going to look like, well, y squared times whatever is left. Over here, y cubed divided by y squared just leaves me y, because I'm taking 2 of them out. Over here, I take out 2 of the y's and I'm left with just the 3. And it is a positive 3, so I'm going to make it plus 3. So that's what I can factor out. I can factor out the y squared there. Over here, I can't factor out y squared because there's only one y here and no y's here. I can't even factor out a y. But 4 and 12 share common factors of 4. So I'm going to factor out a 4 from each of them. And that is a positive 4. So I'm going to say plus 4 because I have this term here attached to it. And that's going to be multiplied by what's left. Well, 4 divided by 4 gives me y. And 12 divided by 4 gives me a positive 3. And at this step, you should notice that you can factor again. And I'm going to look at both these terms together now. What can I factor out of this term here and this term here? Well, I can factor out that y plus 3. So in doing so, I'm going to multiply everything by y plus 3. And what's left? Well, if I factored out y plus 3 over here, I only have y squared left. And if I factored out y plus 3 over here, I only have a positive 4 left. This is not technically how you write this because we want the y squared first due to standard form stuff. So you normally are going to see this written as y squared plus 4 times y plus 3. And when you actually do this, you can FOIL this out, and we'll check our work here. So step 4 is going to be FOIL to check. So let's do y squared times y gives you y to the third. Y squared times 3 gives you a positive 3y squared. 4 times y gives you a positive 4y, and 4 times 3 gives you a positive 12, and you will note that this is the same thing as our original, so we know we did it right. But yeah, those are the steps for doing this. It takes practice, so we are going to do a few more examples today, and it also takes the ability to realize special cases from yesterday. So they will pop up here and there. But yeah, we're going to do a few more examples like this. Then I will show you how to factor trinomials using this method, However, you're probably going to stick with the slide and divide for that. So if you are following along on the PowerPoint, get rid of all that. And our next example is 4n cubed plus 8n squared minus 5n minus 10. Just keep in mind your signs here. You don't treat them any differently, just keep in mind what they are. So when you do your factoring and stuff, you know what your signs tend to be. And again, we're going to do this by grouping. So step one is to group them. So I'm going to group these together, and I'm going to group these together. And then I'm going to see what I can factor out of each of these, thinking they are binomial terms here. So here I have 4n cubed, and here I have 8n squared. Well, looking at just the numbers, 4 and 8 share a common factor of 4, so I can take out a 4. And then n cubed and n squared share common factors of n squared. So I'm going to divide it by n squared. And again, I'm going to do that to each term. So 3n cubed divided by 4n squared is going to leave me with just n. But remember, I'm multiplying this all by 4n cubed, or squared there. So I'm going to leave me with just n. And then 8n squared divided by 4n squared. The 8 divided by 4 gives me a positive 2, so don't lose your signs. And then the n squares you're going to cancel. So I'm just left with 4n squared times n plus 2. And again, I just factored out the 4n squared. Divided each term by 4n squared and brought out the 4n squared. Over here, I'm going to do something similar. I'm going to see what factors they share. They both share a factor of a negative 5 here. Because keeping in mind this is a negative 10, I know negative 10 has a factor of negative 5, 2 times negative 5. And this is a negative 5 here, and I know negative 5 has a factor of negative 5 times 1. So in this case, I am factoring out that negative 5. It's going to leave me with a negative 5 out front. And what's left? Well, negative 5n divided by negative 5 leaves me with just n. And negative 10 divided by negative 5 leaves me a positive 2. So just watch your signs there. This is negative 10 divided by negative 5, giving me a positive 5, or a positive 2. Negative 5n divided by negative 5 gives me a positive n. And this 5 is negative because that's what I factored out. It is a negative 5. You will also note, next step is to factor both of them. So what can I take out of both of these terms? Well, you'll note that they both have an n plus 2 in them now. So I'm going to factor out that n plus 2. So over here I factored out n plus 2. And what am I left with? Over on this side, if I factored out n plus 2, I'm left with 4n squared. And over here, if I factored out n plus 2, I'm left with negative 5. And again, we really don't like writing it in this format. We like to flip it around to the higher degree monomial is first. So we're going to write that as 4n squared minus 5 times n plus 2. And again, you can check this by foiling. So we're going to FOIL to check. So go ahead and FOIL this. 4n squared times n gives you 4n cubed. 4n squared times 2 gives you a positive 4 times 2 gives you 8, and then n squared. And you'll note this is looking pretty good so far because it's matching this. Negative 5 times n gives me a negative 5n, and negative 5 times 2 gives me a negative 10. And this does match my original, so this here is my good answer here. Just so you know, we did check it. This here is your answer for this. That is the answer factored. I'll walk you through another one. Which here is 5t squared plus 20t cubed. I'm sorry, this was to the fourth. This is cubed plus 6t plus 24. In this case, you'll note we don't have a t squared term. That's fine. We can still factor it. It still has 4 terms. We're still going to group them together. I'm going to group these two together, and I'm going to group these two together. Here I can factor out a 5t cubed, right? I can take 5 out of 5. I can take 5 out of 20. And I can take t cubed out of t cubed, and I can take 3 t's out of t to the 4th. So I can factor out the 5t cubed. So I'm going to write that over here, and then in parentheses I'm going to write what I'm left with. 5t to the 4th divided by 5t cubed is just going to give me t, because the 5's cancel, and 3 of the t's will cancel, leave you with 1 t left. 20t to the 3rd divided by 5t to the 3rd. The t to the 3rds are going to cancel, and 20 divided by 5 gives me a positive 4. So I just factored out the 5t cubed. Over here, what can I factor out? Well, I got a t there and nothing there, so I can't factor out any t's, but I got a 6 and a 24, and I can actually factor out that 6. And that's going to leave me with me factoring out the positive 6, and what's left is 6 divided by 6 is 1, leaves me just with t there, and 24 divided by 6 gives me a positive 4. And again, you'll note that whatever's in parentheses here I can now factor out. So t plus 4 I can factor out. So I'm going to go ahead and factor out the t plus the 4. That's going to come out to the front. And what's left is a 5t to the 3rd and a positive 6. And again, I'm going to rewrite that so the 5t to the 3rd is first, and the t plus 4 is in the back. You can then FOIL to check. FOIL it to check, so 5t to the 3rd times t gives you 5t to the 4th. 5t to the 3rd times 4 gives you a positive 20t to the 3rd. 6 times t gives you a positive 6t. 6 times 4 gives you a positive 24. And you can see we went back to our original there. Hi Nora, you're late. Yep. It is recorded, but I'll do some examples from your homework. I know there's at least one I want to do, because one turns out to be a perfect square and you might not realize it. But the second part of today's lesson is factoring trinomials by grouping as well. And honestly, I'm going to go over it just because your book goes over it. You're going to want to slide and divide for these. Just so you are aware. But you're going to want to slide and divide for these. So if you want to follow along with our example here, I'm just giving you bigger numbers here, but you can still slide and divide. Squared plus 25q minus 25. And again, like before, you can slide and divide this out, but let's do it by grouping. So before you group it, you want to split up this term here so you have 2 sets to group. So how do you get 25 out of all this? Well, it's going to come from you multiplying your first term to your last. So step 1 is multiply a times c. So you want to do your a term times your c term. In this case, a times c is going to be 24 times negative 25, which is going to equal negative 600. Okay. Then step 2 is going to be your hard part. Step 2 is you need factors of negative 600. I should write it because I'm generalizing it. Factors of a times c that add to b. So your b term here is 25. So I got to sit here and I got to think, okay, what are some factors of 600 that are going to add to 25? So this factor plus this factor has to equal 25 because b is 25. Sitting there doing that might be a while for you, but that's just because it's a large number. You can use a calculator to help figure it out. And I want to say it's going to be 40 and 15. So 40 and 15. Due to the fact that this is negative and this is positive, this is technically a negative 40 and a negative 15, I believe. No, those are positive. Sorry. Your two factors. Yeah, because they have to add up to positive 25. So one of these is negative. Which one's negative? This one's negative. So it's a 40 and a negative 15. So then you're going to rewrite your middle term split up into those factors, though. So we have 24q squared plus 40q and minus 15q minus 25. And that way you have it split up so you can sit here and you can do your grouping like we just did. And you can group it out. Again, this here is going to be the difficult part, is finding those factors. And that's why I showed you the slide and divide method, because it makes that a lot easier. And slide and divide will work for this as well. This is just another way of doing it. Here we can divide out 8q. So if I factor out 8q, I am left with 3q plus 5. Over here I can factor out a negative 5. That leaves me with 3q plus 5 as well. And then you'll note that I can factor out the 3q plus 5. And that's going to leave me with 8q minus 5 and 3q plus 5. Just looking at it closely to see if there's anything else you can do. Neither one of these are perfect squares. They are not the difference of perfect squares, so that looks like about it. We can FOIL to check it. So 8q times 3q gives me 24q squared. 8q times 5q gives me that 40q. Negative 5 times 3q gives me that negative 15q. And negative 5 times 5 gives me the negative 25. So that's making sense so far. And when you add those up, you get 24q plus 25, that's q squared, plus 25q minus 25. And 24q plus 25q, yep, that's the same thing as up here. So this here is your answer. It works out. But that's how you do them. Again, slide and divide will also work for this. So if it comes to a test, whichever way you're more comfortable with. Factoring by grouping can be fun, so it is another option for you. Any questions on where things came from at all? Things are making sense to everybody. Again, this does get recorded, so you can go back and review it. But your practice today is page 499, 5 through 25 odd. So you go ahead and do that. I think there's one in there that turns out to be a perfect square that I wanted to do. I think it's number 7. So let's take a look at number 7, just so you can see what happens. Use some things. So this is 27 t to the third plus 45t squared minus 3t minus 5. So let's go ahead and factor this by grouping. Again, we're going to group the first two terms together, and we're going to group the last two terms together. When we do that, we're going to see what we can factor out of both of them. So here we have a 27t to the third and 45t to the second. I know I can take out t to the second. And 27 and 45 both share a factor of 9. So I can take out 9t squared, and that leaves me with 27 divided by 9 gives me 3. T to the third divided by t squared gives me t. And that's being added to 45 divided by 9, which gives me 5, and the t's will cancel. Over here, I can actually take out a negative 1. And I'm going to do that so all my signs change, and I can deal with positives instead of negatives. So be aware of that. I can divide each by a negative 1. Then I'm going to take out the negative 1, and this is going to become positive 3t and positive 5, because the signs are just going to change when I divide by negative 1. Doing so, I can then look at this, and I can take out the 3t plus 5, and that leaves me with 3t plus 5 times whatever's left. 9t squared is left, and negative 1 is left. This is actually not your answer, even if you were to rewrite it. I will rewrite it over here, just because, again, we want the higher power first. But this is actually not your answer, because if you notice, this right here is the difference of two squares. So this is what we did yesterday. You had problems like this yesterday. You should note that I can take the square root of 9 equals plus or minus 3, and I can take the square root of 1 equals plus or minus 1. So you can actually take the difference of two squares for this. And when you do so, just like you did yesterday, your 9t squared minus 1 is going to be broken up into, the square root of 9, which is 3t, minus 1, and then you're also going to have the 3t plus 1. So that does get broken up into the perfect square. So your final answer is actually going to be this, breaking this off and then tacking on the 3t minus 1. So it's going to turn out to be 3t minus 1 times 3t plus 1, because of the perfect square, and then the 3t plus 5. So this here is actually your answer. And when you FOIL that out, you should be getting this up here. So just as a reminder, those do pop up when I was doing the work. That's the only one I saw like that, but I also did not finish all the problems, so I didn't do all the problems for this yet. But that's the one that stood out. So with that, please get that started for at least the next 15 minutes, and if it takes longer, do so, but I'll stay on if you have questions or if you want me to do another example of things. It's really just grouping them, factor out what you can factor out, rewrite it, then factor out again. So you just got to factor twice here. And if you're doing it right, you should note that everything that ends up in parentheses here tends to be what gets factored out, if it is even factorable. Sometimes you will get trinomials, quadrinomials, however you get that, just you can't factor. That's possible too, and we'll talk about what that means in another chapter. But for right now, all of these are factorable. You should be able to factor all of them. So if there's any questions on any of them you don't understand, you can ask now. So 13, again, you're going to group the first two terms and group the second two terms, and you're going to see what you can factor out. Let's see what we got. They're both divisible by 2m squared. 20 and 18 don't have any other factors besides 2 that they share. Okay, so we're going to factor out 2m squared, and that's going to leave you with 20 divided by 2 gives you 10. 3, or m to the third divided by m squared gives you m. And 18 divided by 2 gives you negative 9. Keep in mind this is a negative 18. So that gives you negative 9, and the m's will cancel. Over here you can factor out 4. I think 4 is the highest you can get there. So I'm going to factor out a 4 for that. It is going to be a positive 4. And when I factor that out, I'm going to get 10m here and a minus 9 again because that is a negative. So you should note that these are going to be the same for these cases. That's not always going to be the case. If they are different, then you really just can't factor it. But due to the fact that you're practicing factoring, and they're always going to work out today. So here we're going to factor out that 10m minus 9. So I'm going to divide everything by 10m minus 9. And then I'm going to multiply it at the beginning just to get rid of both terms. That's going to leave me with 2m squared here. And that's going to leave me with positive 4. I'm going to rewrite it as 2m squared plus 4 times 10m minus 9. What you should be doing is looking at that because you can factor something out of this term. So we're going to go ahead and factor something out of that term. I can divide that by 2 as well. So I'm going to come and put 2 out here. That leaves me with m squared. 2m squared divided by 2 gives me m squared, plus a 2, which is 4 divided by 2, times 10m minus 9. So this here is your answer. So just be careful. Factor out as much as you can. Double check your stuff. Make sure you're factoring everything out. That was 13. Is there anything else? Keep in mind you're scheduled to have a test by Friday, which is the end of the chapter. So this is the last section in the chapter, I believe. Yeah, so tomorrow you're looking at your chapter review. Friday you're looking at your test. Can you also do number 9? I think I'm doing it wrong. Yeah, of course. this is 9 for Deirdre. Okay. Again, group the first two terms and group the second two terms. The first two terms, you can take out 5x squared. That's going to leave you with 5x squared times, and then 45 divided by 5 gives you 9. X to the third divided by x to the second gives you x. 20 divided by 5 gives you a positive 4. And x squared divided by x squared gives you a 1. You don't write it. It cancels. Over here, you don't have anything you can take out, but I am going to show you to take out the 1 just to keep yourself a little organized here. So technically we are going to take out that 1, and that's going to leave me with 9x plus 4. It doesn't change anything. Then I'm going to factor this, and when I factor this I can factor out the 9x plus 4. I put the 1 there because it's really easy to lose it later, just so you know. So I'm going to get 9x plus 4 over here, and then what's left is this 5x squared, and it's actually getting that plus 1. So don't lose that plus 1. And then this I'm going to rewrite the other way. 9x plus 4, and oh, I'm sorry, I'm just copying the same thing. Wow. I'm going to rewrite the other way, 5x squared plus 1, just so my x squared term is first. Then I'm going to do a quick double check to see if I can factor either of these. Anything, nothing is a perfect square, nothing is the difference of two squares. So it's looking like that is my answer, and I'm going to stop there. And yeah, that's what the book's saying too. So that's what you got. Just be careful with that 1. It's really easy to lose it because it does end up over here. And you can't factor anything out. Just factor out the 1 and pretend it's happening. Is there any other questions? Want me to do any more of them? You can always email me and I can show you how to do them there. Questions from yesterday's work, if anybody had any from that. Which again, wasn't too difficult. You're just going to have to recognize the cases when you see them, and even if you don't, you can always factor things out like we've been doing in sections before. You can always check things by foiling. So if you get not sure you have the right answer, foil it, see if you get the original problem. I'm not sure which selected answers are in your back of your book either. So. Okay, if there are no further questions for today, I'm going to end it. If you're working on that and you come up with a question, send me an email and I'll help you out there. But thanks for joining in. Thanks for your cooperation and have fun doing your math.